Yo, what's up guys? So this is the first video to the channel. It'll be going over IPs and subnetting. This is just going to be a basic overview on the topic. We could go more in depth later, but this is just for a surface level understanding of what these topics are. So what is an IP? So IP stands for Internet Protocol, and IPs are a way for computers to identify each other and send and receive information. So IP addresses are similar to street addresses in that computers use IP addresses to send and receive information, just like how a normal address would send and receive packages. So IPs work at the networking layer of the 7-layer OSI model. The OSI model is a little bit out of the scope of this video, but we will have another video covering the OSI model later. So for now, just know that it works at the networking layer. So moving on, this is what your typical IP version 4 address looks like. So there's 4 numbers separated by 3 periods. So the first 3 numbers represent the network ID. The network ID is basically the identification for the subnet or the network that this host is a part of. The network ID doesn't represent a single computer. It's the group of computers that are interconnected to form a network. The host ID is the identification for the specific computer on that network. So combine the network ID and the host ID provides one IPv4 address. So each of these numbers has a possibility of 1 to 255, and the host ID has the same. However, the number 0 is reserved for the router or the default gateway, and 255 is a way to broadcast messages to the network. So in reality, the host IDs only span from 1 to 254. So this is a 32-bit address, each section having 8 bits with 4 sections. So a bit is a storage in the computer for memory, and it could hold either a 1 or a 0. We'll go into bits and bytes in a later video, but all you need to know is this is 32 bits in memory. So these 32 bits can be converted by using 2 to the power of 32 to see the possible combinations of IPv4 addresses. So this results into roughly 4 billion possible addresses, give or take. However, a problem that we run into in our modern age is there are more than 4 billion devices in the world right now. So this creates a problem where there's not enough IP version 4 addresses to go around. So a new technique of IP version 6 was created. So IP version 6 addresses are a lot bigger, and they use an alphanumeric addressing method. So this is what a IP version 6 IP looks like. Compare that to the IP version 4, you could tell that there's a lot more possible addresses to assign to different devices. So this IP version 6 address totals up to about 3.4 times 10 to the 38 possible addresses, which is a 128-bit address. So because IP version 6 addresses are so accessible, we assign IP version 6 addresses to individual computers instead of IP version 4. Instead, we assign IP version 4 addresses to network IPs. Combining both host IPs and network IPs results in the topic of subnetting. Subnetting is basically a way of preserving IP version 4 addresses while being able to assign internal IPv4 addresses in a network. So I have this analogy of a cul-de-sac. Likewise, in a cul-de-sac, a subnet is protected from the outside and the world. So imagine that these streets forward traffic and information between computers, and when the information goes to the router having a IPv4 public address forwards it to the internal IPv4 addresses for individual computers, like the houses in a cul-de-sac. Subnetting is very useful in being able to have IPv4 addresses inside a network without disturbing other networks. As you can see, this is the typical format for internal addresses, 192.168.1.hostid. So the router has a public IPv4 address, which doesn't look like the internal. So the public IPv4 address is what the router uses to communicate with other routers to send information back and forth. Also note how the host IDs aren't sequential, in that there's not 1, 2, 3, 4, 5, etc. It's 3, 5, 18, and so on. So this is because when a new device connects to a network, the router randomly assigns a host ID to that device. So once the router has that ID and knows what computer it's talking to, it could forward traffic to and from that computer while having a table showing which IPv4 matches up to which computer. So that concludes our brief lecture about IPs and subnets. I hope you found this helpful. Thanks for watching.